Good morning everyone. Myself Vijay Kumar and previously we were discussing about the chapter classification कि chapters को कैसे हम लोग classified किए थे. उसके बाद हमने कुछ चार्ज की प्रॉपर्टीज़ के बारे में डिस्कशन किया था कि जैसे चार्ज जो होता है एक फंडामेंटल प्रॉपर्टी होता है एंड चार्ज एग्जिस्ट इन टर्म्स ऑफ इलेक्ट्रॉन एंड प्रोटॉन्स, ये सब चीज़ें हमने डिस्कशन किया था. उसी चार्ज की प्रॉपर्टी को हम आज आगे बढ़ा रहे हैं. तो आज हमने कुछ बेसिक टॉपिक्स के कुछ बेसिक प्रॉपर्टीज ऑफ द चार्ज हमने डिस्कस कर लिया था कि चार्ज फंडामेंटल प्रॉपर्टी होता है, चार्ज दो तरीके का होता है एंड अपोजिट चार्जेज एक दूसरे को अट्रैक्ट करते हैं एंड सेम चार्ज एक दूसरे को रिपेल करते हैं. ठीक इसी प्रकार हमने बात कर ली थी कि चार्ज इनवेरिएंट होता है, चार्ज एक स्केलर क्वांटिटी होता है. आगे हम इस चार्ज की और प्रॉपर्टीज़ के बारे में डिस्कशन करते हैं. तो लेट्स सी, आज हम बात करते हैं कि जो चार्ज होता है, चार्ज इज ए कंजर्व्ड क्वांटिटी. चार्ज इज ए कंजर्व्ड क्वांटिटी मीन्स चार्ज एक कंजर्व्ड है, चार्ज कंजर्वेशन होता है, चार्ज कंजर्व्ड होता है. दैट इज मीन दैट चार्ज को हम ना तो क्रिएट कर सकते हैं और ना ही हम चार्ज को डिस्ट्रॉय कर सकते हैं. तो देखिए, अगर हम बात करें कि कंजर्वेशन ऑफ चार्ज क्या होता है, अगर हम कंजर्वेशन ऑफ चार्ज के बारे में बात करें तो हम ये बोल सकते हैं कि किसी आइसोलेटेड सिस्टम के लिए जो चार्ज का एल्जेब्रिक सम होता है वो हमेशा क्या होता है, कांस्टेंट होता है. द एल्जेब्रिक सम ऑफ चार्ज, द एल्जेब्रिक सम ऑफ चार्ज फॉर एन आइसोलेटेड सिस्टम रिमेन्स कांस्टेंट. क्या बोला गया कि किसी आइसोलेट सिस्टम के लिए जो चार्ज का एल्जेब्रिक सम होता है वो हमेशा कांस्टेंट होता है. इसी को हम क्या बोलते हैं बच्चों, कंजर्वेशन ऑफ चार्ज बोलते हैं. दैट इज द मीन दैट इफ यू वांट टू डिफाइन द चार्ज कंजर्वेशन देन वी कैन से दैट द सम ऑफ चार्ज इज इक्वल टू कांस्टेंट, but the condition that the system must be isolated. So for an isolated system the sum of charge is conserved, the sum of charge is constant, that is called as a conservation of charge. अब देखिए, हम आज इस कंजर्वेशन ऑफ चार्ज पे डिस्कशन करने वाले होते हैं और ये एक बहुत ही इम्पोर्टेंट है, बहुत ही एक अच्छा टॉपिक है जहाँ से प्रीवियस एग्जाम्स में बहुत सारे क्वेश्चंस पूछते हैं. तो हम इस चार्ज कंजर्वेशन के आज एप्लीकेशंस पे बात करेंगे. तो लेट्स सी दैट एप्लीकेशन ऑफ चार्ज कंजर्वेशन. एप्लीकेशन ऑफ चार्ज कंजर्वेशन कि इस चार्ज कंजर्वेशन की क्या क्या एप्लीकेशंस अपने पास होंगी. उसमें सबसे पहले हम बात कर लेते हैं चार्ज रीडिस्ट्रीब्यूशन के बारे में. चार्ज रीडिस्ट्रीब्यूशन, आई थिंक सबने सुना होगा कि चार्ज रीडिस्ट्रीब्यूशन क्या होता है, फिर भी हम एक बार और बात कर लेते हैं. चार्ज रीडिस्ट्रीब्यूशन का मतलब ये है कि मान लीजिए कि आपके पास से कोई स्फेयर था और इस स्फेयर को चार्ज गिवन था Q1. लेट्स सी इस जो स्फेयर है इसकी रेडियस है R1 एंड लेट्स सपोज दैट दिस इज द अनदर स्फेयर विच हैविंग द रेडियस R2 एंड द चार्ज इज Q2. नाउ देयर इज ए चार्ज दैट इज द Q1 and Q2 on the both spheres. Now we have to study about the charge redistribution. Let's see that we are connected both the sphere by a conducting wire. Then what happened? Then that is happened that charge is transferred from one body to another body. Whenever let's see that the potential, we have seen about the potential. So the potential of the sphere is actually the k q1 upon r1 and this one is potential v2 is equal to k q2 by r2. Now let's suppose that the potential V2 is greater than V1. So you have studied in the previous classes that charge is transferred from the high potential body to the lower potential body. So in our case we have seen here that the potential of the second body is larger in compared to the first body. So in this case actually the potential is transferred from so the charge is transferred from body 2 to body 1. In this case, let's see that this is the charge is going to in the body 1. So after the equilibrium condition, let's suppose that this sphere which having the radius r1 and this sphere having the radius r2. Now after the redistribution of the charges, let's see the charge become q1 prime and q2 prime. So at the equilibrium situation, just we have imagined that, just we have supposed that at the situation of equilibrium, the potential of both the sphere become equal, because of if the potential, there is a potential difference, then charge is transferred from one body to another body. But after the equilibrium situation, what happened, that the potential of both the sphere become equal. In this situation, let's see that potential of the V1, that is V1 prime, is nothing equal to what k q1 by r1, and the potential of the second system is nothing but, the potential of the second system is nothing but k q2 prime by r2. Now there is a v1 prime and v2 prime, and we have seen that in the equilibrium condition the transfer of charge become 0, that means the whole of the charge is transformed, whole of the charge is become redistributed. After this process, there is no transfer of the charge. So in this situation we can say that the potential of the body 1 and the potential of body become 2, potential of the body 2 become equal in this situation. So from here we have reached at the conclusion that the v1 prime is equal to the v2 prime, because of in the equilibrium situation the potential of both the bodies become equal. So in this case, if you want to represent it, then the k q1 by r1 is equal to k q2 prime by r2. In this situation, the k and k is cancel out to each other. So here we can treat it q1 prime upon q2 prime is equal to here r1 upon r2. So this is the very important situation we got here, that q1 prime and q2 prime are the charges after the redistribution. So in this process, actually q1 prime upon q2 prime just equal to the ratio of their radius. So from here we have reached at the conclusion that q1 prime and q2 prime is nothing but equal to r1 upon r2. Right now this q1 and q2 are the charges after the redistribution. So now our goal is to define the q1 and q1 prime and q2 prime in the absolute value, just like q1, q2 and r1 and r2. And this type of question has asked in your exams. Previously this kind of questions has asked in your exam. Last year NEET has also asked this type of questions, and JEE Mains, JEE Advanced, some type of exams in which this type of question has asked. And so right now just think about this system. Just think about this system. Here there is the sphere 1 which having the charge q1, and there is a sphere which having the charge q2. So in this whole process, if you are going to representing, then in this situation actually the charge is conserved, because of these system are actually the isolated system. So we can treat here that q1 plus q2 is equal to q1 prime and plus q2 prime, because of the charge is conserved. So from here, if you are reaching at the conclusion, so we can say that by the charge conservation, so what does the charge conservation says? So the charge conservation says that in the condition of isolated system, the algebraic sum of charge is always constant. So in this situation we can treat here that q1 prime plus q2 prime is just equal to the q1 plus q2. This is known as the charge conservation. So here we have two equations. The first equation is actually the q1 prime upon q2 prime is equal to the r1 upon r2, and the second equation is just telling that q1 prime plus q2 prime is just equal to the q1 plus q2. Right now our goal is actually we have to define this q1 and q2 in terms of r1 and r2 and q1 and q2, because of initially we have the situation that we have q1, that q1 charge on the sphere of radius r1 and q2 charge on the sphere of radius r2. So from here let's see, give this is as equation 1 and this is equation 2 right now. So if I add 1 in the both sides in the equation 1, then this one is actually the q1 prime and q2 prime plus 1 is nothing equal to r1 upon r2 plus 1. This is the normal situation. I just added 1 in the both sides. So, there is nothing effect, and there is nothing effect on the equation. So, from here actually this is 1 and this is 1. So, in the previous in this section the q2 prime is actually the LCM. So, in this situation this one is actually the q1 prime and q2 prime, and this is equal to this is the LCM R2, and in this situation this become R1 plus R2. So, just see here, this is the q1 prime and q2 prime, and this is q1 prime plus q2 prime, and we have seen that q1 prime plus q2 prime is just equal to the q1 plus q2. So, in this situation if we are going to treating, then we can say from here we can say that this is become equal to the q1 and q2. So, from here this one is actually the q1 and this one is actually the q2 and this one is actually the q2 prime. So, this is become equal to r1 plus r2 upon r2. This is the normal situation, and right now we have seen that our goal was actually we have to represent the q1 prime and q2 prime in terms of the q1, q2 and r1, r2. So, from here you can see that there is only the variable that is the q1 prime. So, we have to conclude that the q2 prime is nothing but this is become equal to r2 upon r1 plus r2 into q1 plus q2. So, this is the value of q2 prime in terms of r1, r2 and q1 and q2. Same as it is if you want to represent the q1 prime. So, the q1 prime is just become equal to, that is actually the r1 upon r1 plus r2 into q1 plus q2. So, this is actually the equation. So, these two equations are very useful to represent the charge redistribution in the hollow process, that is the q2 prime is just equal to r2 upon r1 plus r2 into q1 plus q2. Same as it is we can represent q1 prime also, that is actually the r1 upon r1 plus r2 into q1 plus q2. Now, the situation is, just think, we have represent that q1 prime upon q2 prime is equal to r1 upon r2 is equal to r1 upon r2. So, from here we have seen that q1 prime into r2 is equal to q2 prime into r1. q1 prime into r2 is just equal to q2 prime into r2. Are you getting my point? And right now just I have to multiply both the equations by r2 divided by r2 and by r1 into r1, and both the sides I just going to multiply with the pi. Are you getting my point? So, in this situation if you are just treating, then just let's say this is actually the q1 prime and this one is actually the pi r2 square, and this is actually the r2, and this one is actually the become q2 prime and this one is actually the pi r1 square divided by r1. So, from here if you this is the area of the second, this is actually let's see this is going to multiply with the 4 pi. So, this is a 4 pi r2 square and this one is equal to the 4 pi r1 square. So, from here actually the 4 pi r2 square is nothing but the area of second sphere, and 4 pi r1 square is nothing but area of first sphere. Are you getting my point? What I am to say? And this one is actually the let's see this one is actually the A2, and let's see this one is become to equal to A1. So, right now from this equation if you are going, then in the situation actually this one is equal to the q1 prime into the A2 upon r2 is just equal to this one is actually become q2 prime into A1 upon r1. So, from here if you are going, then this one is actually the This one is actually the q1 prime upon a1, q1 prime upon a1 into 1 upon r2 is just equal to q2 prime upon a2 into 1 upon r1. So from here we have seen the charge upon area, the charge upon area, that is represent actually the density, that is represent actually the areal charge density, areal charge density. This represent as a areal charge density, which is called as a sigma. So from here actually we have actually this one is actually the sigma 1. If you want to represent, then this one is actually the sigma prime, that is actually the q1 prime upon a1, and this one is actually the sigma prime, that is actually the q2 prime upon a2. So if you want to write, then this is become actually equal to, this is become actually equal to sigma 1 prime upon r2 is equal to sigma 2 prime upon r1. So from here if you are going, then we just write that sigma 1, that sigma 1 prime into r1 is equal to sigma, sorry, this one is actually the I just write there, this is actually become the sigma 2. So from here this is actually the sigma 2. So this is actually sigma 2 upon r1, sigma 2 prime, sorry, sigma 2 prime upon r1. So sorry, this one is actually the sigma 1 prime into r1 is equal to sigma 2 prime into r2. So and this is actually become to equal to constant. So from here we have reached the conclusion that sigma 1 prime is inversely proportional to the radius sigma prime. So from here we have reached at the conclusion that is actually the sigma prime is inversely proportional to the radius. So whatever we are going, if a situation is arrived just like that, and there the radius of curvature is become large, so in this situation the charge distribution at the position is actually the small. So from here actually the sigma is inversely proportional to the radius. So this type of question has asked in your NEET exam. This same question is asked in your NEET previous year NEET exam, that is actually the sigma prime is inversely proportional to the radius, sigma prime is inversely proportional to the radius. And sometimes this type of question is asked in the JEE exams also. So just let's see what type of question just JEE ask. So the situation is just like that. This is the situation. This is actually the spherical symmetry. These are actually the curved paths. So this is the curved path 1, this is the curved path 2, and let's see this is the curved path 3. And right now this one is actually the sigma 1, this is actually the sigma 2, and this will actually become to the sigma 3. There is a 3 sigma, and we have to arrange the correct order of sigma 1, sigma 2 and sigma 3. So here we have seen that if the radius of curvature is large, in that situation the charge density of that curved path is actually to become small. So the charge density is just inversely proportional to the radius. So here you just imagine that this is become actually the curved, this is become actually the curved, and this is become actually the curved. So let's see, this is the radius r1, this is the radius r2, and this is the radius r3. So from here if you want to conclude, then the r2 is very less, and r1 is less than the r1 is greater than the r2, and r3 is greater than the r1 and r2. This is the correct order of radius. So right now we have to represent the correct order of the sigma. So in this situation actually the sigma 2 is greater than sigma 1 is greater than sigma 3. So the sigma 2 is greater than sigma 1 is greater than sigma 3. This is the correct order of the charge density. This type of question has asked in your JEE exams, and these type of questions actually and mostly time this type of question is asked. Right now we have reached as a result in the charge redistribution process, that is actually the q1 prime is equal to r1 upon r1 plus r2 into q1 plus q2, and the same situation actually the q2 prime is nothing equal to r2 upon r1 plus r2 into q1 plus q2. So here we have the value of charge redistribution, q1 prime and q2 prime. Now just see, there is an example. Let's see, we are taking some example. So this is the radius, this is the sphere of radius 10 meter having the charge actually the 100 coulomb, and right now let's see, this is the another one sphere which having the radius is equal to the 200 meter, 20 meter. The radius is 20 meter and the charge is given to the 200 coulomb. Right now the question is asked that if in the situation, if I just connected both the spheres by using a conducting wire, then find out the charge after the redistribution process, whatever after there is a redistribution of the charge. So in the process of redistribution, what is the final processing the charge in the equilibrium situations. So here let's see, I just want to calculate the potential. So the potential is actually the k q1 by r1 for the v1, and for the v2 that is actually the k q2 prime, k q2 by r2. So from here let's see, the v1 is nothing but k, q is nothing but the 100 and r1 is nothing but actually the 10. So this is become to the 10k, and right now the v2 is nothing but the k, and the q2 is actually the 200 and r2 is actually the 20. So this is also become to the 10k. So here there is a result, that is actually the potential of both the spheres is become equal. So in this situation, in the previously we have seen that if there is a no potential difference between the conducting in these spheres. So in this situation there is no charge redistribution because of the potential of 1 is equal to potential of 2. So the q1 prime is equal to the q1, q1 prime is equal to the q1, and q2 prime is equal to the q2 because of there is no redistribution of charge, because of the charge is redistributed only in the situation when there is a difference in the potential, but in this situation there is no difference in the potential. So let's see, we are going to taking some more example. So the example right now, this example tells that, let's see, this is the sphere which having the radius 5 meter and the charge having actually the 40 coulomb. Let's see, this one is actually the one sphere, and this is the another sphere which having the radius is actually let's see, the radius is 10 meter and the charge is actually the 60 coulomb. So here there is a two sphere, and one is actually the radius of 5 meter and the another one is actually the radius of 10 meter. Now the potential of the one sphere, if you want to calculate, then this is actually the kq by r. So this is actually the k and the q is 40 and the r is 5. So the v1 is nothing but actually the 8k, and for the v2 if you want to calculate, so v2 if you want to calculate, then k q2 by r2. So this is actually the k, and the q2 is nothing but actually the 60 divided by 10. So this is become actually the 6k. So from here, and the potential of the one is actually the 8k and the potential of the second is actually the 6k, and in the situation actually there is a potential difference and the charge is transferred from the higher potential to lower potential. So in the situation actually the potential of the body 1 is large in compared to the potential of body 2. So in the situation actually the charge is going from the body 1 to 2. So the first situation, and the first situation is actually this way, the situation 1 is actually that the charge is going to transfer from body 1 to body 2. Now let's see, in this example if there is a charge 40 coulomb, then after the redistribution process this charge become reduced and this 60 coulomb charge become increased. So how much charge is going to be the transfer? First I have to calculate that what is the amount after redistribution on the both process, and next I will calculate that how much charge is going to be the transfer in the both situations actually. So let's see. So this one is actually the q1 prime is nothing but actually the r1 upon R1 plus R2 into Q1 plus Q2. This formula we have actually the derived. So let's see this in Q1 prime, that is actually the R1. So the R1 is actually the 5 and R1 plus R2 is actually the 15, and this one is actually the 40 plus this one is become actually the 60. So the Q1 prime is nothing but 1 by 3 into 100. So this is become actually the 100 by 3 Coulomb. This is become actually the charge on the body 1. And now if you want to calculate the charge on body 2, then the charge on body 2 is just become equal to Q2 prime, that is actually the R2 upon R1 plus R2 into Q1 plus Q2. So in the situation actually the Q2 prime it just become equal to the R2, that is 10 divided by 15, and this is actually become 40 plus 60. So here this is become equal to the 40 plus 60. So this is become actually the 2 by 3. This is become actually the 2 by 3 into 100. So this is become actually the 200 by 3 Coulomb. So here just see, this is actually the charge on 1 and this is actually the charge on 2. So and this is the new charge on 1 and this is actually the new charge on 2. Now the our aim is actually that how much charge is going to be transferred, how much charge is going to be transferred. So here if you want to calculate the amount of charge transfer, so the amount of charge transfer if you want to calculate, then and then on the system 1, previously the charge having the Q1 and after the redistribution the charge become Q1 prime. So the difference of the Q1 and Q1 prime will tell that how much charge is going to be transferred in the redistribution process. So now previously it has a 40 Coulomb charge and after that it becomes 100 by 3 Coulomb. So after it becomes 100 by 3 Coulomb. So this is actually the 120 minus 100 by 3. So this is actually the 20 by 3 and this is approximately equal to 6 Coulomb. So how much charge is going to be transferred in the whole process? So the charge is actually the 6.6 Coulomb is going to be transferred in the whole process during the redistribution of charge. Thank you.